Matt Reardon, just down the road, Nutrien Ag Solutions. Last year was the open house of the place, just off 45, and he's here to explore how Illinois weather patterns will impact our growing season. Matt is a frequent guest. I talk to him on a regular basis. First of all, always available, which I appreciate. Always good information, always timely information, and local information. So appreciate that too. So please help me welcome atmospheric scientist, one of my favorite titles in the business, Matt Reardon from Nutrien.
This is pretty cool for me. I live just down the road. I grew up here in Champaign, and I don't know, looking at the names on this list, the other people here, a lot of familiar faces, people I respect, and then my name's up here too, so that's pretty cool. It's humbling to be up here. We are in the shadow, I think it's behind me, of Assembly Hall, or the State Farm Center, is what they call it, and I took a gamble. I went and said, I might have a few Illinois basketball fans in here, like myself. Was I correct in that gamble? There you go, that's enough. I did see, and this is okay, some Purdue hats in the back. Apologize for what happened last week. I will say, some of us are like, oh no, what's wrong with Purdue? I think you guys will be just fine as long as you got that bearded Steve Nash. But with respect to who's up on the screen behind me, that is Keaton Wagler, obviously like our all-world freshman at this point. I think Keaton Wagler has a few lessons for us with respect to meteorology and maybe where we're going in 2026. And you're probably like, Matt, where are you going with this? All right. I think about where we were in the summer of 2025. I'm a huge Illinois basketball fan, as is my family, was at the games this year. And everybody, all the players get to campus, and some of the, beat writers start seeing some of the practices. And they start telling us, their take on who's going to be a good player, who's going to be a contributor. Well, this freshman shows up, and you start hearing a few rumbles like, well, he could contribute this year. He actually looks pretty good, especially for a true freshman ranked, he's a pretty poorly ranked recruit. And then we come around to fall, like they get through their equivalent of training camp and media day, and they're like, I don't know, this Keaton Wagler guy, he might be the first guy off the bench. Then the first few games comes around. Now he's starting as a true freshman 18-year-old. And so we're like, wow, that's really impressive. We might have a player here, we have to keep our eye on. Well, a few more weeks go through the season, and suddenly we're like, is he our second best player now? He's scoring like 10, 15 points a night. A few weeks after that, we're like, is this guy our best player? Jump to a few weeks after Christmas, we're like, this is maybe the best freshman in the Big Ten. Jump to 2 weeks after that, we're like, is this the best player in the Big Ten? And now there are some people saying he's a top 2 freshman in the country. He looks like a top 6 NBA pick. And the point I bring this up is it's great for Illinois basketball. I've been having a ton of fun watching him. His 46-point performance was like astonishing. And what I saw here is a classic thing we see in meteorology all the time. We actually saw it with the winter storm that just impacted the west, or I should say the south and the eastern U.S. The trend is your friend. The trend is your friend. So where something is trending is likely where it's on its way to. So that trend that we saw, where he kept surprising us, we should not be surprised if that trend continues. What that might mean for our basketball team is really great. What it meant for the eastern U.S. and the ice storm was not great. We see on the screen here, I'm glad this tweet came out. This was a forecast from the GFS AI. So if you don't know, NOAA and NCEP, that's I believe the National Center for Environmental Prediction, they just released a few weeks ago, if you don't know this, it's paid for by our tax dollars, a AI-backed weather model. It was actually a partnership between NOAA out of College Park, Maryland, and Google's GraphCast AI system. It's a deep learning model originally developed out of London, their DeepMind outfit. And when you're looking at a forecast for the winter storm that came through, and I think this forecast was valid for like last Saturday night or Sunday morning when the storm was kind of at its peak strength. Now this forecast was from like early to middle of January. The one you're seeing on the still here. I'm going to play it forward in just a second. And you're going to see this forecast update for that same time period in that forecast, closer and closer and closer, ultimately up to the day of the event. And I'll play that again. Its first forecast, this GFS AI system, which performs better than the legacy GFS, started out with the storm primarily impacting the eastern U.S. and pulled it all the way back. I'll play that again. So now we're more concerned maybe the eastern Corn Belt or Pennsylvania, pulling it further back. Now we're concerned about Texas all the way up through northern Louisiana into northern Mississippi, Tennessee, and that snow trended, watch in Illinois, up, up, up. Remember at like the middle to last part of last week, we were like, yeah, we might get 2 to 4 inches here in Champaign. By this weekend, we thought, well, maybe get 5 plus. We woke up on Sunday morning to 6 inches with snow falling and wind-swept interstates, unfortunately. The trend is your friend. I don't know, maybe national champion MVP. That'd be kind of cool. If we look at just the snow swath this week, we finally got clear weather to get a good satellite picture here, and it's kind of hard to see with the lights, but the white stuff you see in the middle of the continental US, unlike a lot of the other white returns that you see there, that's snowpack. And you can actually draw a line from Mexico near El Paso, just over the border where they had snow, all the way up through Texas, Oklahoma, Arkansas, portions of Mississippi, and ice in northern Louisiana, heavy snow up through the Ohio River Valley. I'd say heavy snow here if you've looked outside, all the way up into Canada. This was a massive, widespread, impactful winter storm. We worry about these every year. I'm hoping this was the last big one just because of all the impacts. There are still, I just checked, well over 100,000 people without power still in Tennessee and Mississippi. You know their high temp today is like 10 degrees, and they're still without power there. Got this satellite shot. This is just over the Midwest. We took this yesterday morning. You can see Illinois just totally snow covered there, except for that like getting over to like I-88, maybe I-80 and north, stretch through Iowa there, and then you get back up into the snow further north of there. It's cool to see the Great Lakes there causing that lake effect snow over Michigan, like Superior. That brutally cold air, -5-degree air coming over relatively warm lakes that retain that heat from summer helped produce that lake effect snow that's been ongoing. We've had a huge lake effect snow year, kind of went unheralded with these recent winter storms, but they're getting a ton of snow up there in Michigan, and we're snowed in here. I took this was IDOT. If you're ever worried about like a drive from across the interstates during like a big snowstorm like we recently saw, there's 2 kind of tricks that I'll give you. One is you can go to IDOT winter conditions or just search like IDOT winter, and they put up this map. This map is updated regularly. It's really reliable, and that's where the interstates, that purple color is snow-covered interstates, and you can see all the state highways there. The county routes are obviously snow-covered during a big snowstorm event. But on Sunday morning, this told you if you wanted to take a drive on I-74, 72, 57, you were going to have a really rough time. And anyone who tried to drive that morning knows what it was like trying to get around. Another kind of trick that you can do, this one is maybe even a little bit more reliable. Google Maps. You actually like don't have to put in a destination, although it's nice to do if you're going to go a long way. You can actually just pull up Google Maps on your phone or like your browser, and there's a little toggle in the bottom left. Traffic, i.e. like green, yellow, red for how slow the traffic is moving, is usually turned on by default, but if it's not, turn it on, and you can see how fast the cars are going on the interstate and where traffic jams are occurring. And I always pull this up to see where the winter conditions are like really getting bad on the roadways. So I took this picture. This was yesterday. There has not been snow falling in the Mid-South for well over 48, 72 hours at this point, let alone ice. And their interstates in the rural areas are still all backed up with traffic jams because of how much ice that they had down there. So if I was traveling, right, between like Winona, Mississippi up to Memphis, you can see the traffic's bumper to bumper on the highway. Always look at this if you're going to travel in winter weather. Just get an eyeball of how fast those interstates are moving. Google does this, by the way, because we're all driving around with these. So if you're using Google Maps and you have your location turned on, they're tracking your location, and they can see how fast you're moving. So if all of a sudden everybody on I-57 is going 25 miles an hour, they turn it and make it orange. If everyone's going 4 miles an hour, they make it red. It's funny, everyone's talking about the winter storm, and they're asking me, Matt, when are we going to get thunderstorms back? When do we have severe weather? Well, that season tends to start maybe late February, the extreme early side of it, or into March and April as well. Obviously, I'm sure we'll have storms to watch this year. But my first response was, I had this question 2 days ago. I was like, I know this is going to sound surprising, but we just had tornadoes like 2.5 weeks ago at the end of December. December 28th, I'm not going to call it a tornado outbreak, but any tornado reports at the end of December are newsmaking here locally. Had one by Mount Zion, one further up near Effingham. These did some damage. There was actually a rescue with some firefighters to our west of a house that had collapsed. Luckily, no major injuries with that, but EF1, maybe EF2 tornado came through. We had thunderstorms and warnings going off on a day when we were trying to watch basketball. So these can happen in Illinois in the off season. So we get winter storms here, and 2 weeks later we're going to have tornadoes. I always keep an eye on this map in winter. This is the snowfall anomalies this winter. We started this accumulation, at least with respect to this map, on October 1st. So what we're looking at here, areas that have received below normal snowfall up to this date. Those are in beige, let's call it orange. Areas that have received more snowfall this year, those are in that kind of purple color there. You can see what I said earlier about that lake effect snow. Plenty of snow there. Plenty of snow in Champaign, Urbana, where we're standing here. It doesn't take long to figure that out if you look outside, but further to our east, Indianapolis has had a ton, the eastern Corn Belt. And there's some moisture now, a little bit of a savings bank out there, 7 inches of snow, not quite half an inch of rainfall equivalent there, but if that melts, that'll get into soil. We can use that in the new year. And I'm a little bit concerned, you go up toward the northwest, they've actually had some decent rain, strangely, this winter, because it's been warm enough there, but they have a lack of snowpack. And if I took, and I showed you past years, where South Dakota, North Dakota, Montana, Nebraska had bad snowpack, if I told you all those subset of years, you'd find a lot of drought years locally up there in those same years. So we like that snowpack. The fact that there's snow going in the ground into our new growing season keeps me happier than not. It's not a home run. We've had snowy years where we've had drought issues, but more often than not, if we have no snow over winter and lack of rainfall, we're going to be concerned about drought in 26. That's not the case for where we're standing here. Unfortunately, with that snowpack comes high temperatures and low temperatures that look like this. This is the low temperature forecast here from this morning, just Wednesday morning here. If you're noticing that those like really cold temperatures are curiously over like southern Illinois, southern Indiana, and Ohio, not like Minnesota or Maine, that's where we just had that heavy snowpack built in. Fresh snowpack makes for very cold overnight lows. Because fresh, heavy snowpack, it's like a big sheet of ice. First of all, it's white. It's actually more reflective than sea ice in some cases. And all that sunshine that we're going to get all day today, it's going to send it right back up. It's not going to absorb any of it. So we're not going to get much warmer here today. Then overnight, it radiates any heat very effectively back up into the night sky, and we just bottom out those overnight temperatures. So the heavy, fresh snowpack like we have now for a few more days is really suppressing those overnight lows, keeping those below zero temperatures around for a little bit longer. Now, as that snow kind of sublimates, that means evaporates, as it gets kind of messed up, as you walk on it, you allow more heat to get absorbed into the darker parts of the snow, quite literally, and those overnight lows tend to just rise even without a big weather change. We're not having a big weather change over the next 5 days. You're going to see those overnight lows stay low, start climbing back up as we work through some of that snowpack here. Another story we're watching, I'll mention this now just because that trend is your friend, right? We're watching this low spinning up this weekend here, kind of similar to the last one, off the eastern seaboard. Now, I just showed you a trend of 4 forecast updates right here. If we're going to use that trend as your friend, I'd be a little bit more concerned if I was in the Carolinas, maybe up toward Boston, Massachusetts. I don't think it's going to go much further west. I wasn't able to get the latest trend as your friend forecast here, but it's kind of keeping that just offshore. But I think the Carolinas are in for a heavy snow event, potentially with some high winds and a blizzard warning. That doesn't happen very often, I can tell you, for like the Barrier Islands, and then potentially up into Massachusetts as that thing swings east. But we're watching that Keaton-Wagler trend with the storm system, trying to forecast where it's going. If you look at the ECMWF model, I just showed you the GFS one before. These are the same forecast updates for the same time period. If you're a fan of the ECMWF, you're seeing a different trend here. So it's kind of the job of a meteorologist to know which model's handling it better and which trend is more legitimate. In this case, they're disagreeing. That can happen. They run on whole different model suites. And right now, we actually surprisingly think the GFS has a slightly better handle on this. That's not always the case. The ECMWF tends to beat our model more often than not. It's like you can think of like a 90% A- student. That's the ECMWF. The GFS is like a B to B+ student. So 85% versus 90%. It's about that accuracy measure difference between the two. I want the American model. I'm an American. I want our model to be the best. It's public, so I'll give it some credit for that. I mean, it's paid for with our tax dollars, but it's actually open. You can go review the model and try to improve it if you want. And the ECMWF model, for as good as it is, if you want to pay for that, it's like thousands of dollars per year. And it's got a lot of private funding as a result of that. So the fact that we're like neck and neck with it, I think is still pretty impressive. All right, I want to show you guys, this is some data analysis that I did earlier this year, actually in fall, because I do a lot of kind of research like this. I wanted to put together a graph of how many times I have watched the Pixar movie Cars in my life. And I think Cars came out in 2006, so I started the graph that year. And when it came out, I was frankly young, if you can't tell by looking at me. And so I watched it once. I wasn't like a huge fan of it relative to the other Pixar movies. Like it came after a stretch of like Toy Story 2 was great, Monsters Inc. was a home run, Finding Nemo was a home run, and then Cars was kind of a little different. It's kind of like a little odd in my opinion, anthropomorphized Cars, I don't know. I wasn't a huge fan of it, so I only ever saw it once, never bothered to ever see it again. Well, that changed in the last 2 years. I've now seen Cars, I have to update this graph here because we've had 2 months since I made this, and I'm probably over 70 or 80 times I've watched this movie. Does anyone know what happened to me about 2 or 3 years ago? Yeah, I had twin boys, and they're absolutely obsessed with cars. They will watch it literally multiple times per week if we let them. We try not to. One is home right now with grandma. He's sick, and so he's going to watch Cars like 3 times. He's going to get it as often as he wants. But it's actually now, having seen it 85 times, I've come to like Cars. It's got a very interesting story, very like it came out right before the recession, and it kind of has a story about Main Street there that I think resonated well at the time, just coincidentally. And I'm a big fan. That's not why I'm here to talk to you, so I should move on to the next slide. Now, Pixar might be relevant to what I just talked about, these different models that we have to forecast the weather, because when we start watching these Pixar movies, I just like to be, I don't know, I like to look up fun facts about stuff. It's just a thing I like to do. So if I watch a movie that I really like, or we see a kids movie and I think it's engaging, Monsters, Inc. being one, my kids are starting to get into that now, so probably gonna watch this one 70 times next year. I read the Wikipedia page for Monsters, Inc., like who directed it, what was the backstory, how'd they come up with this ridiculous idea of a monsters universe. And I found this astonishing little nugget. It's like buried at the bottom of the Wikipedia page. And down there it says that in order to simulate and render Sully's hair for the movie in a realistic way, mind you, this came out in 2001, they had to physically simulate with computers all 2.3 million of Sully's hair to make him look realistic when he was moving around. And they said they spent millions of dollars on this, Pixar, to make Sully look realistic. And I was astonished by that. I'm like, I gotta learn more about this. So I went through some sources. I found this super obscure trade magazine from like 2003 on like the Internet Archive, and it had a full write-up on how they did this. They flew in physicists, they flew in computer experts, because when they first showed the test groups to the kids, Monsters, Inc. test footage that they had CGI rendered, the kids did not like it. The first iteration of the monsters were too scary. Sully in particular, when they tried to put hair on him, they weren't simulated at all, so it was just like frozen. And there's a lot of movement and action in this. There's a scene in the Himalayas where they're moving around and the wind's blowing. Some of you are looking at me like I'm crazy, but a few of you out there are like, yeah, I remember that scene with the Yeti. And so they had to physically make his hair look realistic, because the first test group saw footage like this, and they were like, no, we're not gonna watch this movie. This looks ridiculous. They didn't even give Mike arms until closer to the time it premiered. And so they had to spend millions of dollars, quite literally, physically calculating how his hair would move as he swung his arms around. I think he like wears a tie in the movie as the wind was blowing on him in the Himalayas to make it look realistic. So a bunch of kids would go see the movie, and they did it, like hundreds of millions of dollars in revenue. They made all this money back, and then some. It was a great idea to fly in those physicists and pay them a lot of money. And they spent a lot of money on the compute. The actual most expensive scene was the one I just referenced in the Himalayas, where he trips and falls, and they had to physically simulate. They actually had someone come in and help them make the snowflakes fly in the wind and accumulate realistically on his hair throughout this like 4-minute scene where he's out in the snow. This costs a lot of money, time and effort from a lot of people smarter than I am. And what they probably don't realize what they're doing, or maybe they do, I just mentioned they were smart, is they're doing what we're trying to do with our physical modeling of the atmosphere. The models I just showed you, the GFS, the ECMWF, we have plenty of others that I can show you as well. This is all possible because in the early 20th century, mathematicians like Lewis Fry Richardson, who we're looking at, other very smart people, go back to the end of the 19th century, could name a lot. They really found a lot of these governing equations, the mass equations that determine how our atmosphere works. A lot of those are up there behind you. I'm not going to talk through that. But they determined that these physical equations governed a lot of what happens in our atmosphere. And this Lewis Fry Richardson guy, he came up with this thought experiment. He actually had it peer-reviewed. He said, theoretically, now that we know, how the wind works, now that we know how temperature advex, what have you, he came up with a thought experiment. He said, what if we took all the station observations, of which there are plenty in the 1930s when he thought of this, and if we knew what the temperature was, or the pressure was in Champaign, and we knew what it was in Chicago, and we knew what it was in Decatur, if we knew what it was in Peoria, if it was raining there, this was before satellites, it was before radar, but accounting for all these different pressure variables, I could create a dome if you gave me an infinite budget. That was a thought experiment. I'm going to put mathematicians in a grid around the world, and they'll all have their little room. And they're all going to take these station observations and then calculate all those ridiculous partial differential equations I just showed you on the slide before. This is going to take a lot of money, time, energy, food, bathrooms, and then they will all feed their solutions back to the orchestrator in the middle. He'll put the forecast together. He said, theoretically, give me an infinite budget, and I could do this. And he had it peer-reviewed, and people were like, well, yeah, technically, but obviously this is completely unfeasible. This would be like a multi-billion-dollar project today in our USD right now. And what he probably couldn't have known at the time, in the 1930s, that we were at the advent of inventing the transistor, and therefore the computer revolution came some 2 to 3 decades later. We now have his dome in the ECMWF server room in Bologna, Italy. We have one in College Park, Maryland. We have them all over the world now, where we feed in observations from Champaign, from airplanes, from radar, from satellite, temperature, soil moisture, pressure, wind, relative humidity. We feed them into the dome that's in our computers now, and it spits out these forecasts, the kind I just showed you from the GFS or ECMWF. This is what we call numerical weather predictions, kind of the backbone of modern forecasting for the weather, and it's how we've done it really over the last 40 to 50 years, and we've made dramatic improvements in it. We are literally physically simulating the atmosphere, or at least that's how we used to do it. I think we'll continue to do it that way, but that changed in 2023. I still remember this day. It was in fall, it was November. I got a call from a colleague of mine, and he said, Matt, you need to read this paper that's out in Nature, very reputable science journal. And he said, and you know when like somebody offers you to like read a new book or a new movie, or they like send you some like article from the Wall Street Journal or something, and they're like, hey, can you read this? It's really great. I think you'd find it interesting. I'm like, you want to be a good friend and read it, but you're busy at work, so you just kind of bookmark it, try to get to it later if you can. I was going to try to do that because this was a long article. And he's like, no, you really need to read this. And I read it, and I was shocked. I'm glad I read it when I did. Google's DeepMind outfit, I already mentioned them out of London, in 2023 released this paper. They said they have a new weather model. This has never been done before, a new brand new weather model run entirely on an AI backend. So this model knows no physical calculations. It does not know at all how our atmosphere works. It doesn't care about any of Louis Fry Richardson's groundbreaking work. We're literally just feeding weather models or feeding weather data from around the world to the AI, and we're saying predict the weather. Well, Google's DeepMind outfit did that. They created this weather model, and in the paper they said that they beat our current benchmark for our best weather prediction, ECMWF. Not only did they beat the ECMWF by a pretty decent margin, but the ECMWF takes 7 hours to run. So when we get the new weather data from Champaign and everywhere else, we feed it into the ECMWF. It costs a ton of money to run, a ton of time and energy. Very powerful servers running all those physical calculations, which are very compute expensive. That's what they found out, Pixar, trying to simulate Sully's hair. It takes 7 hours before we get the results. We have to sit there and wait 7 hours, and why our weather's happening? Well, it's getting stale. Google's model at the end, they said they could run it in 60 seconds. Give it the data, it'll run in 60 seconds, produce the answer. And it runs off these things called neural networks, particularly the DeepMind outfit they used a graph neural network. Now, I'm not going to stand up and try to explain how neural networks work, but maybe the simplest explanation is if you feed it a handwritten digit, it takes that, it vectorizes it, so it's going to turn that handwritten 7 into a bunch of numbers, basically from 0 to 1,000 across the pixels on the screen. How many of those are colored in? If they're colored in, they get a 1. You feed all 784 of those pixels into the model there. There's quite literally billions of those little nodes inside these neural nets. We run that billions of times, and if you do that long enough, and you tell it what answer is right or wrong at the end, it's going to go back through all those little nodes, somewhat analogous to how our brain learns information, and it's going to eventually figure out patterns that match reality. How that 1 is a 1 is somewhere embedded as information in that neural network. Now, it just costs a lot of money, and it just takes time. You just have to run this over and over and over again. That's what these AI models are doing. Now, curiously, they're black box models. And what that means is we don't really know how they work. We don't really know how they understand the atmosphere. I could tell you why the GFS tends to be biased in some respects. I can't tell you what's going on in the AI models. It always trips people up. We've seen a big sea change in this. Google has continuously updated their model. They just did it again in fall. They finally released it publicly. We quickly adopted it on our website and our other materials. I was quite literally looking at it for this winter storm, and it did very, very well. And so it's been impressive to see the updates here. NOAA has partnered with Google. I think that was the right decision to make. They just released this about a month ago, a partnership where they have this new model. We rushed to kind of implement it to get it into our system. I showed you this tweet earlier. The GFS AI did very, very well. So our forecasts are getting better. They're getting a little bit cheaper. And we have more to base our opinions off of. I think this is all good. This is good news for weather forecasting. It's good news for agriculture. And so much of what we do, so many of our decisions are dependent on the weather. Now, they're not wildly better. They still get things wrong. I showed you the trend earlier. It was off base to begin with. But I'm glad we're leading the charge in this, both us and the ECMWF. China's doing it too. They have Huawei's Penghu weather. It's based off a very similar system. The graph on the left, I won't talk through the one on the right, but the graph on the left shows you our forecast improvements just over the last 20 years. So our accuracy 10, 7, 5, 3 days out, it's just getting better and better. And I would expect these improvements to to accrue, right, over the next 10 to 20 years with these AI models. Our hurricane track forecast error over the last 40 years, just where is a hurricane going to be and how strong is it going to be, 2 days out, 5 days out, 7 days out, to give these people time to prepare for these terrible storms, those have been improving significantly over the last 40 years. And these AI models, with how quickly they run, is a huge benefit. It's a huge benefit. I can think of a great case, Hurricane Otis, a few years back, I believe this was fall of 2023. On the morning, Tuesday morning, that Hurricane Otis would eventually make landfall. We woke up to a rather weak, we almost didn't name it a tropical storm because it looked more like a depression. We named it a tropical storm and we said, well, we think it's going to skirt northwest. It might stay a tropical storm, might be a tropical depression. Watch out coastal Mexico. You might get 30-mile-an-hour winds and some heavy rain. It was sort of an afterthought on our plate that morning. We had other storms going through the Midwest. We had other hurricane concerns over the Atlantic. No one was really thinking about Otis. Well, over the next 6 hours, Otis strengthened unprecedentedly from a weak tropical storm into a Category 5 hurricane. The largest modern forecasting bust by almost any measure. Imagine you're in Acapulco, a town with hundreds of thousands of people. Unfortunately, it's fallen on bad luck. It used to be a huge tourist town. You're sitting there. Today, a Cat 5 hurricane is going to make landfall. You wake up that morning, and nobody knows. No meteorologist knows. It was our biggest forecasting bust. Acapulco was devastated from this hurricane. Strengthened over the course of one day and slammed right into the bay, which is that little notch you saw the eye go right over. That's why this paragraph at the bottom of that paper in Nature by Google shocked me so much. It said, not only are we better, but we were able to forecast the next 10 days of weather in under a minute. The ECMWF forecast that was going to forecast how Otis was going to strengthen, when we started running it that morning, we had to wait 7 hours till afternoon to get the results. By then, we already had a Cat 3. It was too late. So if we can run these faster and more accurately, our weather forecasting is going to improve. We need that. We get a lot of severe weather here in Illinois. We don't have to deal with Cat 5 hurricanes, thankfully, but we have to deal with stuff that looks like this. If you're curious what it looks like when an EF4 tornado bears down on a windmill, that little stick you can see just to the left of the tornado, this is the video for you. This is by a storm chaser named Stas Speransky. Fantastic footage. We have a saying in the storm chasing community. If the tornado, like visually, is not moving to your left or your right while you're staring directly at it, you've got big problems. And Stas realizes right about now, I got a big problem. And he makes the really wise decision to just get the heck out of there. I don't have the sound for this video, which is fine, but if I did, Stas has a French bulldog named Manny, who's in the back seat of his car, snoring this entire video. So EF4 bearing down, not entertaining for the dog. This footage was from just this year. This was summertime up in Watertown, South Dakota. I can tell you right now, if I'm showing you tornado footage, hail footage, severe winds, derechos through the middle part of the country on dates like this, June or July, we probably grew a pretty good crop. Not where that tornado hit. But if we have severe weather moving through in the heart of the season, like June and July, we typically get it right April, May. The outbreak in '96 right through here, the Urbana EF3, it was in April. If we have severe weather moving through the middle part of the country, this late in the year, we're probably getting enough moisture to grow a pretty good crop. In the case of the Western Corn Belt, too much with the southern rust that we dealt with. We broke another milestone with respect to tornadoes this year. This was a tornado up in North Dakota, a little town named Enderlin. It was initially rated in EF3 when it came through, I believe, in late June. 2 months later, they ended up analyzing this drone footage of a rail car, really a whole train that had been derailed by this tornado. And what caught the attention of the meteorologists and the other engineers who rate these tornadoes was the tanker on the top of the screen, quarter-mile away from the railroad track. And if you look carefully, there are no groove marks in the soil. And those are standardized shapes that we can actually use to calculate wind speeds. I knew it was actually an empty tank, which maybe makes it slightly less impressive that it threw it a quarter mile. But we were able to calculate how much wind it would take to toss one of those a quarter mile. It was 215 miles an hour. As a result, we had our first EF5 in 13 years in the United States, ending a 13-year drought with no EF5. So that's a good drought to have. We had our first EF5 thanks to that train derailment in North Dakota. There's a picture of that storm on a ring camera from nearby Enderlin. Tornadoes at night are just like the hauntingest thing to me. I was very little when the Urbana one came through near my neighborhood east of here. We could hear the debris hitting the house. Since then, I mean, that's why I'm standing up here, is these things scare the crap out of me. So I want to learn more about them. Fortunately, this year, with respect to hurricanes, I mentioned Otis earlier, a lot of those stayed out to sea. Our strongest one, unfortunately, this year was Melissa. That can't be said for Jamaica, where it made landfall on the western side of that island. The hurricane hunters got in this one multiple times and took this incredible time-lapse footage flying right through the eye to take those measurements in the middle that are so valuable for those models that we run. We plug their data that they're risking their lives for right into our models to improve them on these hurricane forecasts. And it's just fascinating to see these videos. 0 to about 40 or 50,000 feet up go those clouds and that stadium effect that you can see there. Those striations, by the way, do you see those like diagonal striations? We don't know what causes those. It's kind of cool to see that footage. Of course, the only way out is to go right back through that eye wall, the most turbulent part of the storm. More satellite footage of Melissa from above. These things run on warm bathwater ocean temperatures. That's their fuel for their engine. When you take that away in the form of mountains or land over West Jamaica, you just sap things with these energy. So that's why you can see it quickly dissipate right over the western part of the island. All right, with respect to 2026, I always tell people, told this multiple times a day to folks, if I knew exactly what was going to play out this year in every single county, if I could paint you right now the USDA Drought Monitor map on August 1st with any high degree of confidence, I love Champaign-Urbana. I grew up here. I like being here with all of you. I would not be here right now on Wednesday in 6-degree Fahrenheit weather. I would be training energy derivatives down in Cabo, drinking a pina colada, because I could make a ton of money. Think about commodities. They sell something called weather derivatives now up in Chicago. So I could just make money on this all year long. If I knew exactly where drought was going to form, who was going to get the rainfall, where the southern rust was going to develop in 2025. All right, I can't tell you that, and I'm not going to try. You should laugh somebody out of the room if they know exactly what's going to happen 6 months from now. What I can tell you is what I'm going to watch for, what I think is going to end up impacting, and what could change between now and April or May that could make or break our season. One of the first things we have to talk about of those different features is El Nino. Now, right now we're in a La Nina. What do I mean when I say that we're in a La Nina? Well, I'm talking about sea surface temperatures in the central tropical Pacific. Let's see if I can pull up an example of those. Right now we're in a La Nina. So if we pull up a map of sea surface temperature anomalies across the globe, then there's a lot going on in this map. I'm looking in the central tropical Pacific. That's west of South America, kind of northeast of Australia. I boxed it for convenience. If the water temperatures there are cooler than normal, we're in a La Nina. If they were orange and red right now, we'd be in an El Nino. That's what we're talking about when we say La Nina or an El Nino. Now, it helps that La Nina and El Nino tend to have somewhat reliable correlations with the weather that's happening here. For example, wintertime La Nina events, we tend to have a jet stream that does that. That's what the textbook says. It tends to blow up in a ridge over the western U.S. California has poor winters with respect to how much moisture they get. And then we get these clipper systems or air out of the northwest that bring cold air into here, colder than average winters, and often a little bit snowier than average as well. That's worked out pretty well this year with respect to what's happened. Now, later in summer, if we were to strengthen into El Nino, big if, and we ask what the textbook says during those years, well, we tend to see more moisture on the right and the mid to latter part of summer. I should say on the left. It is confusing. The red on the left is more precipitation in El Nino years. And the green colors you can see on the right over the Midwest are cooler temperatures when we're in El Ninos in the summer. So that's why we care about that. That's what the textbook says. The textbook's not always right, but this year it is, especially in winter. So right now, Tahiti, right in the middle of that box, they're cold. I shouldn't say they're cold. Their sea surface temperature anomaly right now is like -0.5 to -1 degree Celsius, so you're talking about their bath water slightly cooler than average. And they're having a good time. But what I want to see is if their water temperatures are going to warm up heading into the new year. That's what we're going to be focused on. If I paint you the jet stream, how it's been here this winter, I took this from December 1st out through, I think, January 23rd or 25th. What has the jet stream been doing this winter? Ridge over the west, lack of rainfall in California. I'm getting calls from ski resorts out there complaining, when's the next snow going to come? I'm going to show you the forecast later. I don't have any good news for them. I wish I did. And we've had this big Hudson Bay trough sitting right to our northeast, just funneling cold air into this area. Now, we were warm for a period during Christmas, but we've been cold. We've had these clipper systems come through. I think we have another one coming through like Monday, Tuesday of next week. Not nearly as much snow coming with that one that we just saw, but this pattern has held up pretty La Nina-y, given that we're in a La Nina. Showed you that snow pattern earlier. We're looking at maps like this in the morning. I just took this from yesterday. All those little like white boxes you see strewn across the Corn Belt there, the blue boxes across the southern tier of the US, those are cold air warnings, either freeze warnings or extreme cold warnings. We've seen a ton of these just January. Probably see more. And the jet stream over our heads right now, it looks like that. That's textbook La Nina. Big blocking ridge over the western US, diving down into a trough over our heads. Now, what I was looking at earlier this year in November was this map. These are trade winds over the West Pacific. If I play those streamlines out for you, you see this consistent east to west wind blowing across the Pacific equator, like say from Tahiti over toward Australia. And we see trade winds behave like that. This was in November. We know we're in a La Nina, because that's going to upwell cool water in the eastern Pacific. It's going to drag that across the equator to Tahiti, and we're going to situate ourselves in a La Nina in winter. That came to fruition. That's what we saw, that pattern. Well, recently, we're starting to see those winds turn around right there in the central West Pacific. When we see these in spring, these are often the very first hints that El Nino is trying to work its way back. The warmest water, if you think about that box that I showed you, really the warmest ocean temperatures in the world are over near the Philippines, over in the West Pacific. That's why we see crazy typhoons over there, stronger even than we get in the Atlantic. So if you take winds and you turn them around west to east, from the western Pacific to the central Pacific, back near Tahiti, you're going to drag that warm water back to the central tropical Pacific. Well, we just defined that earlier as El Nino. So if those western winds stay kicking, I want to watch those closely. They're actually going to weaken next week. But if we call these westerly wind bursts, I showed you a map of those, or a chart earlier. Maybe watching that forecast, we keep seeing these westerly wind bursts through spring, we know El Nino's coming. It's going to take more than one of these events. We're seeing one event move through right now. I want to see if we get another in February or March to kick our way out of this La Nina into an El Nino. If we just look at that INSO index, if it's below that black line, significantly so like it is now, we're in a La Nina. If that starts trending above 0.5 degrees Celsius, the top of the chart, we're working our way into an El Nino. And you can see, what did I say earlier? The trend is your friend. Forecast from the ECMWF, they forecast these ocean temperatures out into the future months in advance. What's their forecast for spring and summer, those ocean temps? Big warm up. Strong El Nino chances. That's just one forecast. You can look at a number of different forecast ensembles, as we call them, different members here, all forecasting the same thing, a rapid warm up and those central Pacific sea surface temperatures heading into the new year. Right now, the Climate Prediction Center puts that chance of an El Nino about 60%. And ultimately, what that could do, I'm not saying it will happen here, we know that 60% chance is there. What that could do is make a lot of thunderstorms over the central Pacific. So as the ocean heats up, we talked about that's that fuel for both tropical storms and for convective thunderstorms over the tropics, the kind that can blow up in Florida that we see all the time. And if those start percolating into the central Pacific, that tends to push these ridge-riding thunderstorms right over our heads here in Illinois. June and July, more rainfall, maybe more pest pressure as a result of that, particularly with respect to fungal concerns. Just one scenario we're watching to play out if we see that El Nino develop. Now, if I think about where we're at right now, I actually don't think I included the USDA drought monitor, and I did that for a reason. I often don't look at the current drought monitor, believe it or not. When I wake up, particularly on Thursday, it's not the first thing I look at. What I really look at, I go to that same website, USDA Drought Monitor, I go to the top left and I click on Change Maps. It's one of like the little drop-down menus there, and you can change map it. So you can see how has that drought classification changed over the last X amount of weeks. And I always put in like 8 to 12, and sometimes put in 4. However, is there like a flash drought developing over the last 4 weeks? In this case, because we're in winter, things tend to move a little slower, I put the last 10 weeks. And the trend, again, is your friend, right? The waggler razor, if you want to call it that. What has the trend said? Well, we had a ton of rain in Southern California in December. That washed away a lot of the drought in California. They're starting to see those snowpack deficits occur again. Really, a lot of the lack of precipitation has been across the south and the east. Obviously, that changed here very recently. We're going to have to see how the USDA Drought Monitor updates that. But despite some of the drought that we overwintered in the soil from fall, here locally, we haven't seen a huge change since then over winter. And we do have that snowpack out there, which we can at least melt into the soil eventually here in February. So So I don't see a strong trend in either direction here that makes me concerned about drought locally yet. Another thing we have in play, this is looking at western snowpack anomalies, so not necessarily drought, but snow drought, which works a little bit differently, especially in the western US. This chart, to read it, green is average snowpack accrual over the winter. There's actually, you get into some fun blue colors here. If you're having a huge winter out west, there's not any of that on this board. It's all orange and red, significantly below average snowpack for the skiers and the hydrology in the western US. I actually keep an eye on this heading into our new year. If we build in drought and heat in the western US, we tend to get two things. One, we get less severe weather in spring here, and even more so across the southwest of here, so like the southern plains. So I'm less concerned going into 2026 for severe weather compared to last year when we had plenty of snowpack, which can often be a driver in spring for severe weather here. Now the mechanism of action there, how that's actually occurring, you can think of western US snowpack like a source of cold air aloft. What I mean by that is, if you've ever been to the western US basin, it's 5,000 to 10,000 feet high. You cover that in snow, it's gonna help cool the air over the western half of our continent. That cold air will naturally help sag the jet stream further to the south, where it's blowing right over our heads in spring. Well, I can tell you, if we have a jet stream blowing right over my head in spring, I can tell you what's going to be blaring outside. All right, tornado sirens and severe thunderstorm warnings. So what we might do is end up causing some drought in the southern plains as a result of that. Obviously, more drought and heat concerns where we lack snowpack to the southwest. Maybe less severe weather moving over here as we go through spring. I also put together some analog years here. This was my thought experiment. I wanted to say, all right, how many years, I played out the scenario for you just a second ago, how many years did we start in a weak La Nina, because technically we're in a weak La Nina, and warmed up that summer into any sort of El Nino, as a lot of those predictions think might happen. And all the years that came up are in that top sample there. You can scrutinize them closely if you look. Okay, in all those years that are so, quote unquote similar to this year, what did the spring look like with respect to precipitation? In all those years, we actually had precipitation deficits over portions of the plains, even bleeding a little bit over into the western Corn Belt and over in the mid-Atlantic as well. So our kind of best guess years, if you will, or at least with respect to those sea surface temperatures around the globe, are actually looking more so like a dry trend for spring. And we saw that across the southern plains last year in 2025. We had these dust storms as a result of this. If you remember, the air over our heads at times with the clouds was like orange. Remember in spring, before we put the crop into the ground, we saw pictures like this out of Kansas. Wouldn't be shocked to see stuff like this again as we head into the new year. There's actually a tornado, believe it or not, in the middle of this over in West Texas. I don't know what else to call this besides a big dusty tornado. What do those same summers look like with respect to precipitation? Well, some of them were actually drier than average. Now, I will stress, you gotta look at the color bar. Anytime someone shows you a picture like this. Color bar says that in June, July, and August, that's 3 months where we average roughly 3 to 4 inches per month. At the end of that summer, in all these years, we averaged about a half to minus 1 inch of precipitation here locally. Actually, if you're over in the middle part of the state, it was average. So out of the 9 to 10 inches of rain that we could have got in the summer during those months, we only averaged 1 below that, maybe 9 inches or 8. That's enough to grow a pretty darn good crop, especially if temperatures play along. So what I'm not forecasting here is wild drought concern. Maybe it'd be a little bit more concerned to our south or to our southwest. Temperatures that year, this is another reason I'm not really concerned. A lot of cooler years popping up in these analogs, both in spring and in summer. Now, I'm standing on the stage in January, last year at this time, 2025. Let's be honest, let's come clean. We had drought concern galore. These were the soil moistures, by the way, in fall, before that following growing season in 2025. I mean, just about the worst Mississippi River levels you can have in some locations. A huge lack of rainfall. This persisted through winter, and a lot of us, myself included at times, were concerned about this heading into the new year. And some of those same analogs that we pulled up were way more concerning than the ones I just showed you. Significant drought concerns popped up in the same thought experiment I did last year in 2025 for that growing season. And then compare the map on the right to what I showed you 2 slides ago. See if I can get that back. Is it asking you to sign in, Sam? There we go. So that's where the narrative was last year. When we looked at some of the dynamical models, these are seasonal models that forecasted for summer 2025, they showed stuff like this, hot and dry, especially more so for the western Corn Belt, if anywhere. Those were a lot of the bullseyes were pointing for drought risk in 2025. What happened? It was the wettest summer on record in the western Corn Belt. They dealt with southern rust. We saw pictures like this, orange. That's not dust from Kansas, that's from spores. It's kind of gross. Right? We had too much moisture in a lot of cases to our west. We ended up growing a really good crop, but not where some of these hardest areas were hit. So what I'm saying is the exact forecast 6 months from now is a fool's errand. I can't really tell you what's going to happen. I can tell you what happened in years past and where things are leaning. Also, with respect to that southern rust this year, we saw some of it in Illinois as well. We pulled up a pretty big smoking gun. We went back and looked at all the prior years' leaf wetness accrual and all the recent summers. And 2025 is on there in that black line. And in the middle of July, for just about all these areas that were hit with southern rust, we're actually at average leaf wetness accumulations through the middle of that month. By the end of the month, across the board, they're at their record leaf wettiest year on record by the end of July in a 2-week period. You get that much moisture, that much dew, that much rainfall. Apparently, seemingly, you had this fantastic environment for that southern rust explosion. I think part of that is we've also seen this trend up in summertime minimum temperatures. These are overnight temperatures. So you keep that heat up, you keep that moisture up, that can stress the crop a bit. It also probably means we're pretty wet because that keeps overnight temperatures up, but it also increases that fungal pressure. If that trend stays true, we talked about trends a lot in this talk, this is something I think we're going to have to deal with more so in the next decade than we did in the last two. I went back in the different, that thought experiment I showed you earlier. Every year we started in La Nina, eventually transitioned to El Nino, kind of similar to where we're at this year, and I actually cherry-picked it. Shouldn't necessarily cherry pick this with respect to a forecast, so this is not a forecast. I cherry picked the worst years in that bucket. You can see the ones I picked on there, 23, 06, 02, 91, really hot over the northern part of the country and dry right over here, right through the Corn Belt, especially Kansas. These years we had yield impacts. 2023, we kind of snuck out of it with a late thunderstorm in June and then another one in late July. Now all these years had January sea surface temperatures that looked like this. There's that weak La Nina. We already established that. It had to have that going into the new year. And notice in the Northeast Pacific, I'm talking like south of Alaska, west of Canada, cold water's there, like a little, I'm going to call that like a reverse sea. Cool water's there. Okay, between January and April, these bad drought years, how do those ocean temperatures change? Well, that La Nina there in the middle of the Pacific, it weakened. Well, we know that was the case because that was required for me to go find the year to begin with. We also saw those water temperatures to the Northeast Pacific. They got even colder than where they were in January. And that matters so much where we go in summer, right? If we just think of last year, there's those sea surface temperatures in the Northeast Pacific. Not a huge signal here in either way by April 1st. And quickly, I'll show you over summer. That's always the concern in summer, that we build in a big ridge there. By August of 2025, near the end of that, the heart of that growing season, those water temperatures just got warmer and warmer and warmer in the Northeast Pacific in 2025. What does that do to the jet stream? Well, it sends it up and over those warm ocean temperatures rather predictably. That dives it down through the Midwest, and we had ridge-riding thunderstorms all summer long over Iowa, had tornado videos to watch, and southern rust. So really, as much as I'm talking about that La Nina, which is lingering here in 2025, by the way, all the way through summer, it's those sea surface temperatures in the Northeast Pacific. I'm probably going to watch more than that La Nina to El Nino transition, despite what I just mentioned about it. So here's where we're at, January of 2026, that weak La Nina in the middle of the screen. I went back and I tried to find the year that looked most similar to this year. 26 is on the left, 2018 is on the right, same time. Now, if you nitpick it, you can find differences, but otherwise, they look really similar. I was actually shocked when I pulled that up, that they look so similar. It's really, I mean, they're almost like fingerprints, right? None of them are the same. I'm not saying they're the same, but they're really similar. So now I'm like, all right, 2018, what did we see in spring, March through May? There's that drought concern, southern plains, even over into the western corn belt. It was also cooler. That popped up in a lot of our thought experiments as well, a lot of those analogs. I don't think this is a bad analog for 2026. It's not going to be perfect, I can assure you that. June through August, we were wet, actually too wet in portions of Minnesota in 2018, had some production impacts there. But by and large, wet enough to grow a great crop, maybe a little bit more fungal pressure, and curiously hotter in 2018 than we were in some of the other analog years. Another year that looks similar, I think, is 2014. In spring, March through May, that similar drought concern over that central to southern plains area I talked about earlier. We have drought building in there now, so I wouldn't be surprised if we're dealing with that in spring of this year. Do I think it's going to bleed up here in Illinois? I'm not as confident on that. And curiously, that analog was cooler in spring as well. So maybe some planting window concerns just with respect to cool air. Cool air and dry weather tends to promote more of those frosts later in the planting window. So if we're dry and cold, that helps to bottom out those temperatures a little bit more at night. So it might be a concern if that starts to trend that direction. Now, probably don't have to tell many of you in this room what happened in June through August of 2014, bumper year. All right, what are those same dynamical models that failed so badly in 2025, say in 2026? Guys, I can tell you, I'm not looking at these too closely. They got it really wrong last year. They're never super reliable to begin with, but it is fun to look at them. Curiously, in spring, shows that southern plains drought risk. Doesn't show as much of that bleeding up into the middle part of Illinois or the Corn Belt. ECMWF, we talked about them over in Italy. Their forecast for March through April, and then April through June, wetter. Through this quarter, they're not focused as much on that southern plains drought, maybe over in West Kansas toward Amarillo. What I will show is the ECMWF forecast for the next 10 days. It's going to show you that eastern U.S. storm that we're worried about spinning up here this weekend. Like I said, could see a blizzard warning in North Carolina. And then there's that clipper system coming through next week. I think we might see 2 of them, but I'm talking like 1 to 2 inches of snow. I'm not talking 5 to 6. So there's that La Nina pattern. I'll play it again for you. You can tell the flow's coming out of the northwest. You don't even need to look at the jet stream. Look at those clippers come northwest to southeast, across the Midwest over the next few days. There's Monday. I think we might get a brief shot of snow, and then later in the week, otherwise cold temperatures. And maybe we're getting out now like February 10th there, a breakdown in this pattern. There's the snow forecast the next 10 days. Like I said, not a lot of snow expected through this area, but I think flakes are going to fall locally, maybe 1 to 2 inches. Could see 3 at the absolute max. More of that snow over to the east. Just look at the 10-day average of temperatures, cold for the east, cold for the southeast. Florida this weekend, there's a forecast right now I could show you for Miami, 35-degree Fahrenheit low, Saturday to Sunday night. That's like to the bottom of the state. You're talking like Lake Okeechobee getting down to freezing. I don't think it's going to freeze, but I think temperatures will be freezing. Falling iguana alerts will be issued. That's a real thing. And if I look at the long-range pattern, I'm getting out into February now. This is all the way out to next Sunday, February 8th. And I still see that ridge across the west, that trough across the east. The only good news I have, that ridge is getting so dominant to our west. It's called that La Nina Ridge. It's starting to push into the plains, so it's going to slowly warm up our temperatures. If I want to find you a day where our high temperature is going to have a 3 in front of it, I got to go to like Wednesday or Thursday of next week. Looking a little bit further out into February, this is getting near that second week of February. Still not a huge change. Drought in the west. Told you I don't have good news for the ski forecasters there, and heat there as well. Like I said, though, as we get further along into that second week of February, our temperatures moderating a bit. So highs in the 30s or 40s, lows in the 20s, not highs in the 20s, lows in the negatives. And this was the first day I could definitively say I think we'll be above 30 degrees. This is Friday of next week. So we're still locked in for the next 7 days in this cold air. By and large, the forecast through the 10-day period, you kind of saw this with that ECMWF loop earlier that I showed you. It's going to be on the drier side. We will have some moisture falling, but 1 inch of snow and liquid equivalents, like roughly a tenth of precipitation. Liquid equivalent, also dry in the west and back drier toward the southeast. If I sneak this forecast as far as I can into the future, we start to see that cold back off a bit. Like I said, that second week, let's call that the middle of February, with some warmer than average air. I'm not going to call it warm for mid-February. If we look at those same analog years I mentioned earlier, just as maybe a guide to where we could end up in February, this is looking longer term near the end of the month. It wouldn't shock me based on this and some weakness we're seeing with the polar vortex over the North Pole. We get another big shot of cold air and another winter storm late February. So when we get that brief mild warm up in the middle of the month, wouldn't shock me if that's quickly followed up by more of what you just saw over the last week, unfortunately. I'll finish up with South America, like 6 minutes left here. There was a bit of a story as we went through like December and January of some, I'm going to call it quote unquote dryness entering into Brazil, certainly portions of northern Argentina and southern Brazil that are maybe worth talking about. I'm showing you the really only kind of NOAA data that we have for South America. It can be a little bit harder to get data out of these international regions, but if we look at satellite estimates of drought and soil moisture there's some concern over central Brazil, certainly concern through southern Brazil, northern Argentina, some of the growing regions there. But we haven't seen a lot of this come to fruition. These satellite estimates are not super reliable. So while it looks pretty red, we haven't seen a lot of this really kind of on the ground in terms of the reporting there. Another kind of better estimate, I think, of this is if we just measure how green the growing regions are. So we can bin on the satellite the pixels by which have growing regions. When we do that for Brazil specifically, and we measure that NDVI for 25, 26, right, it's their summer, that is in red, their NDVI. It's actually higher than it's ever been over the last 10 years. Kind of consistent with the production estimates coming out of there that are so high for both soybeans and probably their second crop corn season. So if you're looking for a big weather story out of at least central Brazil where the bulk of that crop is grown, not seeing it right now. Their harvest there also getting along very quickly. Sometimes we kind of, if you want to hope, given the weather market, that we're going to delay that harvest, make that second crop season more difficult for them. We're not quite seeing that. They've been able to get that crop out of the ground pretty quickly. That line in red there, how fast that harvest is undergoing in Brazil. And their corn season seems to be coming along nicely, just getting started with their planting window, obviously, but the forecast right now, if anything, for some of the more high production areas, plenty wet. The good news there is it might delay a little bit of that second crop plant. It might delay some of the harvest that's underway there for soybeans, kind of at the edge of both of those right now. So watching that closely, I think if anything there, the story is they're too wet in the highest growing regions, but there is still that drought in northern Argentina, Uruguay, and far southern Brazil that has persisted into the new year. Our seasonal models, we have those just for South America like we do here. If we go out into their, like, let's call it the June, July, August, so their corn season, that's what this looks like for precipitation departures. Wetter in the main growing regions in central and southern Brazil, like south central Brazil, Mato Grosso do Sul. As you get further south, I just mentioned this, northern Argentina, Uruguay, far southern Brazil, you're still seeing that drought concern hang on. The problem with South America, they're growing so much in that south central portion there, their I states. What happens there is kind of like what happens in here in Iowa. You can complain about drought in Ohio, you can complain about drought in Michigan. If you want to move the needle on where things are going with the carryout, you know it's going to happen in Minnesota, Iowa, Illinois, these other big I states. If you guys want to follow along in a lot of the story that you heard here today, we put a video out every day on YouTube in the morning. So if you just search Nutrien on YouTube, I can guarantee you'll find us, and you'll hear kind of a 30 minutes of what I just gave you here, more so focused on what's going to happen in the next 20 days in the forecast. We also have a website where we put up a ton of the graphics that I just showed you. This is called agweather.com, ag-wx.com. This is just where my colleague Eric Snodgrass and I initially put all these graphics. We found out people really love following along in the models, and so we tried to clean it up a little bit, and we put a lot of content on there as well. I invite you to visit that. And I want to keep you guys on time for lunch, so I will look back at the organizers. I'll take questions if we have time. Do we have time for a question or two?
Yeah, one or two.
One or two.
About thunder in January, creeks run in May. You an old wives' tale guy like that?
Yeah, I love the old wives' tales that I hear from folks. So I've heard other one, lightning on dead wood. Anybody heard of that one? Lightning on dead wood. Makes for a big year as well. There's like a 90-day fog rule. Does that sound right as well? I've looked into a lot of these. I don't see a lot of truth to them in the data, but I'm never going to dismiss them totally because sometimes they're right in the wrong way. I've noticed some of that.
I'm not going to diss my grandmother by any means, yeah. Over here.
Oh, hi. I just had a question about the difference between the AI models and the models that you guys are running. So yours take 7 hours to run, but I imagine that a lot of the bulk, and these AI models now only take about a minute. I imagine the bulk of their time, though, was on that training data set. How many compute hours do they need to train that model?
Yeah, that's a great question. So to actually build in the, for lack of a better word, intelligence into the model, to teach it what's happening, you have to train them first. And I don't know exactly how long it takes, but I can assure you, and you probably know this already based on your question, it's very expensive computationally. It takes a tremendous amount of power. It takes a tremendous amount of semiconductors and chips, and NVIDIA is profiting off that in a substantial amount of ways right now. They just tried to put in a data center in Naperville. The local city council shot it down. There's like concerns over water usage. So training the model, super expensive, and that has to be accounted for. Very expensive, takes a long time to train. Now, once it's trained, then it's good. Then it runs in 60 seconds thereafter. And you only really need to retrain it, maybe once a year. So that's very important. There is that kind of, it's super expensive to run every day for 6 hours versus super expensive just run it once. And I'm guessing the payoff is going to work out once they improve, right, with Moore's Law and everything else. They build more of these data centers that they're going to find it's probably worth it to train it up front. But I still think the physical models will always have their place because they're white box models. We know how they work. We can drill into the physical equation. Like I can tell you what ECM/WF tends to have a cold bias. That's helpful. It's nice to know why something's wrong. What if I built you an AI tornado warning and it went off today? How could you trust it ever again, even if it was accurate like the rest of the year? Whereas if I built you a physical tornado warning model that just looked, well, is there a rotating thunderstorm around you, and it went off today, I could point to exactly what I did wrong, right? You can't do that with AI models, which is sort of scary. It's a good question, though.
Yeah, one over here. By the way, CARS 2 is very anti-renewable fuel. So CARS is okay. CARS 2, please don't get them on the sequel. Okay, over here. Hang on. Okay.
We'll try that again. Matt, thank you for your talk. Speaking from someone not too far away from here, about an hour south, our farm well has not been above 3 inches since July 16th. And which is odd for the fact that our rain gauge said we were 21 inches ahead of our annual average, just as a testament to how much rain we got last spring. My question is there a good way to quantify how much rain we would need to recharge the soil in preparation for spring? Is that a known quantity or something that we could anticipate?
Yeah, it's a good question. So what I can tell you is it's going to be hard to give you a rainfall amount for the reason you just said in your question. We've had plenty of rain if you average it or bin it over a year or 2 years prior, but we're still seeing these soil moisture deficits. And so the problem, we've seen this trend elsewhere in the country, is when we do get these rainfall events, Trent Ford, a local climatologist, he made a great example of this in Illinois with some of the flooding that we saw in Chicago earlier this year. We're getting too much at once. And so you can get 3 inches of rain in an afternoon, you're going to lose 2.5 of that to the river networks. It's going to run off in the parking lots, and it's not going to percolate into the soil. What we want is more frequent light rainfall events. Those get nicely into the penetration into the soil. We don't see as much runoff, and that would probably help raise the soil moisture more than a 5-inch rain event in one day. So it's hard for me to give you an amount, because if it all falls on one day, that's not going to help. I will say with respect to the soil out here, that snowpack is nice to have right now, because as the winds pick up next week, maybe later in February and March, we do have that snowpack. We're at least preserving the soil moisture that's underneath that soil or that snow now. Whereas when you just have bare soil in winter and high winds on top of it without rain, you just zap that soil moisture, just evaporates very quickly. So I like that there's snow out there now. What I'd like to see is that snow melt slowly with light rainfall and a light warm-up slowly over February, and not a huge 70-degree day at the end of February and a ton of rain. We've had that in the past. That would just send a lot of that snowfall down into the streams, down into the river, down the Embra outside here. So the question's more so on, can we get some infrequent light rainfall events, or sorry, I should say frequent light rainfall events, and avoid big flooding rains in spring? Would work a lot better toward improving those soil moistures. And I think a big problem with some of the local wells too, particularly eastern Illinois, perhaps where you're from, if you're like Effingham and east, is that going back like 4 years, we keep seeing fall drought build in. And that fall drought just kind of sapping more of that soil moisture away. Even if summer and spring were super wet, we're losing that soil moisture going into overwintering, where you're not going to change the soil moisture profile very much, just because we're frozen, and 2, we don't get as much water, by liquid equivalent in the winter months.
All right, Matt. Thank you very much.
Thank you.
Appreciate it. A lot of great info there.